So this is the lesson from Tuesday, February 26th. I actually wasn't here, so I'm kind of doing this makeup after the fact. Mr. Grossman taught the lesson for the students. This is a lesson about simplifying mixed ratios. A mixed ratio is what I'm showing here in this first example. If x is to y is 11 to 8, and y to z is 6 to 7, then find x to z. Well, we have two comparisons, and y is appearing in both, but basically the three things involved are x, y, and z. In the first part of the problem, we know that the ratio of x to y is 11 to 8. And in the next part of the problem, we're seeing y being compared to z, y being 6 parts to z's 7 parts. It's the same y in both. Clearly, it's just broken up into different size pieces. So the thing to do here is to look at the y and figure out what's a common multiple of 8 and 6. Use that to change these ratios so that they are linked together. So when I look at y having 8 parts in the first ratio and 6 parts in the second ratio, I can say to myself, well, a common multiple of 8 and 6 is 24. So what I can do is I can say I'm going to multiply this first ratio here, both parts of it, by 3. And the second ratio here, I'm going to multiply it by 4. What happens is I get equal sized pieces then for my y. So x will be 33, because 11 times 3 is 33. And 8 times 3 is 24. And you can see from the second part of the ratio, when I multiply y by 4, I get the 24 I already have. And the 7 by 4, I get 28. So my ratio of x to y to z is 33 to 24 to 28. The question, though, really just asks us to find the ratio of x to z. So my x is 33 and my z is 28. So my ratio of x to z is equal to 33 to 28. So the next example is for you to try. And also to get you to not be frightened by the fractional way of writing the ratios that you see over here. Remember, we talked about that's an acceptable way of writing ratios as well. So when I read the problem, if the ratio of A to B is 3 to 5, and the ratio of A to C is 5 to 9, I need to find the ratio of B to C. Alrighty. Well, I know that the three things involved in this problem are A, B, and C. In the first part of the problem, I learned that the ratio of A to B is 3 to 5. Well, in the second part of the problem, I get a comparison of A to C, A being 5 parts, and C being 9 parts, 5 to 9. I just leave a little space in there because in this case 5 is not being compared to B. So the A, with the 3 parts in one ratio and the 5 parts in another ratio, is the link to the two ratios. It's like in one, A is cut into 3 pieces, and in the other, A is cut into 5 pieces. So I want to get that A cut up into an equal amount of pieces in both ratios, and then it'll be fair comparison. So you ask yourself, what's the common multiple of 3 and 5? And the common multiple of 3 and 5 is 15. So I have to take this first ratio here and multiply it by 5, and then I'll get 15 parts. And the second ratio, I have to multiply each by 3, and that will give me 15 parts there. So when I multiply my first ratio by 5, I get 15 to 25. And in the second part, when I multiply my 3 by my 5, I get the 15. And my 3 by my 9, I get 27. So when these are all split up into equal sized pieces, the ratio of A to B to C is 15 to 25 to 27. In this particular problem, they just want us to find the ratio of B to C. So I can say the ratio of B to C is equal to 25 to 27. Okay. Let's see what other examples we have. Given that the ratio of R to S is 7 to 10, and S to T is 4 to 5, find in part A the ratio of R to T. Okay, give this one a try for, you see how I solve it. Have to use pause to try to solve it. Okay, so hopefully you pause, and here's the thought process. I know that I'm talking about a ratio with R, S, and T units. So the first part of the problem, I learned that the ratio of R to S is 7 to 10. And in the second part, I find the relationship between S and T is 4 to 5. Well, S is split into two different parts in these ratios, so we have to get equal parts. So I have to ask myself what's a common multiple of 10 and 4, and that will help me get my equivalent ratios. Lowest common multiple of 10 and 4 is 20. So I'm going to take this first ratio and multiply both parts by 2, and the second ratio multiply both parts by 5. When I do that, I get that R has 14 parts or units, so S having 20 units, and then I have to multiply my T by 5, and I get 25 units for that. So the ratio of R to T, R is 14, T is 25, the ratio is 14 to 25. Did I get it right? I hope so. All right, in letter B, we're taking the same relationships, but they want us to write the ratio of 3R to 11T. Well, what does 3R mean? It means 3 times R. So you want to make sure that you're using the numbers in the ratio where they've all been made into equal sized pieces, which means we want to use these numbers over here. So 3 times R would be 3 times 14 compared to 11 times T. 11 and T over here is 25, so 11 to 25. When I simplify, 3 times 14 is 42, and 11 times 25 is 275. So the ratio of 3R to 11T is 42 to 275. And I think I have one more problem for you. A little word problem. So same idea but built into a story problem. An alloy, which is just a piece of metal made up of several different kinds of metal, consists of 3 metals, X, Y, and Z. Calculate the ratio of X to Z, given that the ratio of X to Y is 2 to 3, and the ratio of Y to Z is 5 to 4. Okay, so ask yourself which letters are involved in this problem, and we've got X, we've got Y, and we've got Z. So I go back and I read to find that the ratio of X to Z, well, finding X to Z, given that X to Y is 2 to 3, and Y to Z is 5 to 4. So this Y here is broken into 3 parts here and 5 parts here. I need to get those into equal sized pieces so it's a fair comparison. What I need to do is multiply by the common multiple of 3 and 5. So this ratio can be multiplied by 5, and this ratio can be multiplied by 3. So when I multiply the first ratio by 5, I get 10 to 15. And the second ratio, I would get 15 to 12. So my ratio of X to Y to Z is 10 to 15 to 12. Problem's just asking for the ratio of X to Z though. So the ratio of x to z equals 10 to 12. But be careful, because what do you notice about that ratio? Right, it can be simplified to 5 to 6. So the ratio of x to z is 5 to 6. Same idea, just put it into a story problem. So your assignment today is from page 227, numbers